Let's find a sum. It's the sum is 1 times n, 2 times n minus 1, yada yada yada. I have to go to the whiteboard, and I got to work through it. And looking at it, the first thing I do is to sort of like write the sum down. So the sum s is 1 times n plus 2 times n minus 1 plus 3 times n minus 2. And by writing these things down, you start to realize it's really a very simple pattern. N minus 3 plus yada, 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 all the way up to n times 1. So I'm going to write it as a summation now. So I'm going to say it equals a sum, and I want to do one thing at a time. So I'm going to say it's 1, 2, 3, 4, 5, 6, up to n. So I'm going to put this down now. I'm going to say, let's say I equals 1 to n I times something. And here comes the tough part. I'm going to go backwards now. And what do I see? I see 1, then there would be a 2, blah, 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 all up to n. And what would that look like? And that's always a problem for me. I got to write that down. And certainly at 1, I'd have to evaluate the n. So what I'm going to do over here is going to say, I'm going to write this over here for you. We're starting at 1, right? So I'm going to say n minus I plus 1. I always say, I got to think about this, all right? So if I tried, 1, would I get n? Yeah. If I tried 2, would I get n minus 1? Yeah. If I tried n, would I get 1? Yeah. Everything works, by the way. So the next thing comes is like, what are you going to do about that? Well, I'm looking at this thing and I still don't know what the sum is. But what I can do is I can split it into 3 different sums. And to do that, I'll do it one at a time. Let's just expand it. So it's going to be the sum, I equals 1 to n. This is going to be ni. That's not so bad. Minus I squared. That's not so bad. Plus I. All right, we're going to sum that together now. That's 3 different sums, by the way. On the first sum, I can pull out the n. On the second sum, it's just the sum of the integers squared. And the third sum is just the sum of the integers from 1 to n. You should probably know this, but if you don't, you'd have to give up on this stage over here. But the sum of the integers from 1 to n is n plus 1 over 2, minus the sum of the integers squared is a 6 here, on n plus 1, and then 2n plus 1. And the sum of the integers is n plus 1 over 2. All right? Now, by the way, to me, this is an answer. Right? I want to clean it up, though. And someone says, why do you want to clean it up? It just doesn't look right to me. Right? The first thing I would probably do is get a common denominator of a 6. And you would get 3n squared, n plus 1, minus n plus 1, 2n plus 1, plus 3n, n plus 1. All right? And the question is, what do you do about that? Well, I'm going to factor that. And what are you going to factor out? Things that are common. Let's put that down for you. Equals a 6. And I see an n, and n plus 1 common to all terms. Let's write this down. All right, what are you left off with? Well, in the first term, you get a 3, and you get an n. On the second term, you're going to get 2n plus 1. On the third term, you're going to get a 3. Let me just check, see if I did that right. 3n, n, yep, that looks good. Looks great. Let's keep moving. N n plus 1 over 6 times, this is 3n minus 2n minus 1 plus 3. Well, things are getting a little bit simpler. Whoops, didn't mean to do that. n plus 1 over 6. Let's see, 3n minus 2n is just n, and minus 1 plus 3 is going to be plus 2. So I'm ready to write my answer down, n plus 1, n plus 2 over 6. Final answer. All right, n plus 1, n plus 2 over 6. Thank you.